Hello students, in the week 6 session 3 we are going to learn about architecture of 8051 microcontroller, PSW and special function registers. Coming to the content of this session, the first topic is a very important concept, that is architecture of 8051 microcontroller. Later we are going to learn the program status word, that is PSW register, which is also called as a flag register. Later we will see the special function registers available in the 8051 microcontroller. Coming to the very important topic, that is architecture of 8051 microcontroller. You can see the block diagram of 8051 microcontroller. We have 4 kilobytes of program memory, that is ROM, and we have 128 bytes of RAM, and we have two timers, timer 0 and timer 1, which takes the counter inputs. Then we have serial port block which is having a TXD as a transmitter pin and RXD as a receiver pin. Then we have IO ports. As we already know, the microcontroller 8051 have 4 ports: port 0, port 1, port 2, port 3, and each port is of 8 bits, which will form the address bus and data bus. Then we have a bus controller block which control the address bus and data bus. Later we have a very important block, that is central processing unit, which you can say it is a hard part of the 8051 microcontroller. Then we have a oscillator block which supply the clock cycle to the central processing unit. Then we have a interrupt controller block which receives the interrupt from external. Students, we will see the explanation of each block. The first block, which is very important, that is central processing unit. As I already told, the CPU will be the heart part of the microcontroller, that mainly comprises of ALU, that is arithmetic and logic unit, and CU, that is control unit, and other important components. The CPU is a primary device in communicating with the peripherals like memory, input and outputs. In CPU we have ALU. The ALU means arithmetic and logic unit. As its name suggests, it will perform the arithmetical operations like addition, subtraction, multiplication, division, and logical operations like AND, OR, NOT, NOR, etc. And we have another block unit present in the CPU is control unit. The control unit is responsible for timing of the communication process between CPU and its peripherals. Students, coming to other blocks, we have internal RAM block. 8051 has 128 bytes of RAM. This 128 bytes of RAM is further divided into the 3 sections. The first one is 4 register banks, and each register bank contains 8 registers. And the next one is 16 bytes of bit addressable locations. Then we have 80 bytes of general purpose RAM memory. So all the 3 will form the internal RAM. We will see the details in next sessions. Next we have interrupt control. Students, interrupt means if any device or a peripheral needs a service, then it will send a interrupt signal to the microcontroller or CPU. So then the CPU will halt its current operation and it will serve the peripheral which needs service. So we will see the interrupt concept. It is a very interesting topic. We will see in that interrupts in the interrupt concepts in the later sessions. So the interrupt controller consists of interrupt enable register. So there are many interrupts we can enable and disable those interrupts by using the register, special function register, whose name is interrupt enable register. Then we have another one special function register in the interrupt controller, that is interrupt priority register IP, which is mainly used to assign the priority to the interrupts, as if two or more devices needs service at the same time, then the CPU will see the priority list. According to the priority, it will service the devices. So we can also assign the priority to the interrupts through interrupt priority register. Next we have 4 kilobytes of ROM. The 8051 is having on chip ROM of 4 kilobytes, which is for storing your programs. Then we have serial port. In the serial port part is used for serial communication. We have two special function registers in it, SCON and SBUF. SCON means serial control register and the SBUF means serial buffer register. And we also have two pins which are performing serial communication operation, that is TXD and RXD. Later we have 4 input and output ports for interfacing the 8051 with external world. Then the 8051 consists of two timers, timer 0 and timer 1, which can be used either as a timer to generate a time delay, or it can be used as a counter to count the events happening outside the microcontroller. Students, coming to the next topic, that is program status word PSW register, which is also called as a flag register. This PSW is a 8-bit special function register. The main function of this register is to indicate the current status of the CPU, like after the arithmetic operations, whether the carry is generated or not, auxiliary carry is generated or not, overflow is happened or not, like each bit indicates some conditions. So PSW is a special function register which indicates the current status of the CPU. You can see there is a 8 bits, PSW.0 to PSW.7. This register is both bit addressable as well as byte addressable. We have PSW.0 bit is a P, that is parity bit. PSW.1 is kept for future use. Then we have PSW.2 is a overflow flag. The PSW.3 and PSW.4 belongs to the RS1 and RS0, which are the register bank selection bits. Then we have F0, which is also kept for future use, like the user use general purpose bit. You can assign any flag to this bit. Then we have auxiliary carry bit, then we have carry bit. So one by one bit we will study what is the function of the bit. Coming to the carry flag, it is a CY. This flag is used to indicate whether the carry is generated during the arithmetic operations like addition or subtraction. If carry becomes 1, then it means carry is occurred in the addition or subtraction operation. If carry bit is 0, then it means the carry is not occurred. So based on the conditions we can take the necessary steps. So next we have auxiliary carry flag. This flag is set only when there is a carry from bit D3 to D4, that is from lower nibble to upper nibble. If auxiliary carry flag bit becomes 1, then it means the carry is occurred from bit D3 to D4. If auxiliary carry bit is 0, it means carry has not occurred from bit D3 to D4. Next flag is overflow flag, OV flag. This flag is set whenever there is a result of signed number is too large. It means if the result is out of the range, then overflow flag will set. So if overflow flag becomes 1, it means overflow has occurred. If overflow flag bit is 0, then the overflow has not occurred. Coming to the parity flag, this flag indicates whether the accumulator contains odd number of ones or even number of ones. Students, this parity flag will be used in the serial communication. So the content of accumulators, what it is having, it will count the one number of ones. If there are 3 number of ones, then it will be set. If there is a 2, then it will be 0. I mean to say, if there is a odd number of ones, the parity bit become 1, and if there are even number of ones, then the parity becomes 0. Then we have register bank select bits RS0 and RS1. These two bits are used to select the register banks. These register banks are present in the internal RAM. So there are 4 register banks: bank 0, bank 1, bank 2, bank 3. But at a time only one register bank will be active. So which register bank is active, you can come to know by these two bits RS1 and RS0. If both bits are 0, then bank 0 will be selected. If RS1 is 0, RS0 is 1, then bank 1 is selected. If RS1 is 1, RS0 is 0, then bank 2 is selected. If RS1 is 1 and RS0 is 1, then bank 3 is selected. Then we have PSW.1 bit and PSF1 bit. These are general purpose user defined. Students, now we will see special function registers, SFRs. There are some registers in 8051 which are reserved for special functions. These registers together called as special function registers, whose address ranges from ATH to FFH. Students, from the address ATH to FFH, we have many special function registers which perform the special functions. We will see each special function registers and their working functionality and their bit pattern in the coming sessions. Some of the SFRs are bit addressable and some of the SFRs byte addressables. SFRs can be addressed by their names or by its address. Students, now we will see which all are SFRs present in the microcontroller and their name and their address. So very first SFR is our register A. We called that as a accumulator whose address is 0E0H. Then we have register B whose address is 0F0H. Then we have PSW program status word whose address is 0D0H. Then we have stack pointer. Then we have DPL and DPH 8-bit registers which form the DPTR. Then we have 4 port registers: port 0, port 1, port 2, port 3. All these port registers have 8-bit. Then we have interrupt priority register IP 8-bit. Then we have IE register, interrupt enable register, which perform special function in the interrupt. Then we have TMOD registers and TCON registers which helps in the timer operations. Then we have TH0, TH1. These are the higher byte of TH0 and TH higher byte of timer 0 and timer 1. Then we have TL0 and TL1. These are the lower byte of timer 0 and timer 1. Then we have SBUF and SCON registers which have function in the serial communication. Thank you, students.